Hello students, welcome to Physics Foundation Advanced Video Series. Today we will be covering Chapter 1, Revision of Motion in One Dimension. So now this entire video, the theory of this video would be a revision of what you had studied in Foundation Basic in the last year. So we'll do a quick recap and I expect you guys to already know this stuff. I'm only revising it. So if you remember, we had started with defining physical quantities. Anything that can be measured are called physical quantities. They are basically of two types, vectors and scalars. Scalars need only magnitude, whereas vectors need magnitude as well as direction to be defined. Scalars can be added simply arithmetically, like 2 kg or 3 kg plus 5 kg is 8 kg. Whereas in order to add or subtract vectors, we need some special rules that you had studied in addition and subtraction of vectors. By now everybody knows what is distance and displacement and what is the difference between them. Distance is basically the total path length covered by a body, whereas displacement is the shortest distance between initial and final points, or just a straight line, the length of a straight line joining initial and final points. Distance is always positive, whereas displacement can be positive, negative or zero based on our sign conventions. Distance is a scalar quantity, whereas displacement is a vector quantity. We also know what are speed, velocity, average velocity, etc. So let us say a body starts from point A and it moves a lot and finally reaches a point B. If we want to calculate its average speed over this entire motion A to B, what we do is calculate this total path length between A and B and divide by total time taken. So total distance upon total time would give me the average speed. Similarly, in order to calculate average velocity, I need total displacement upon total time. Total displacement क्या होगा? This path length AB. Yes, all these values are average speed and average velocity. But when you move from one point to another, let us say from Pune to Mumbai, and you know that it takes, let us say, 4 hours to cover 200 kilometers, then your average speed from this calculation is 50 kilometers per hour. बट अपने को कॉमन सेंस से पता है कि एवरेज स्पीड 50 है, इसका मतलब ये नहीं है कि गाड़ी हमेशा 50 किलोमीटर पर आवर की स्पीड पे चल रही थी और कभी उसका कांटा इधर उधर नहीं हुआ, नहीं. सो दैट्स व्हाई वी नीड समथिंग कॉल्ड इंस्टेंटेनियस स्पीड. Instantaneous speed tells you what is the magnitude of velocity or speed at exactly this instant, है ना, अभी तुरंत अभी कितना स्पीड है. That is the difference between average and instantaneous. Next we studied how to add two vectors using triangle rule of vector addition. In order to add two vectors, A vector and B vector, what you do is join them head to tail. एक के head को दूसरे के tail के साथ join कराओ. And then the vector joining tail of first to the head of second vector would be the addition of these two vectors. Please note over here that A vector plus B vector is equal to B vector plus A vector, है ना. It doesn't matter in which order we add them. तो यहाँ पे I have taken B vector first and A vector later. An application of this is, let us say a pilot is flying his plane in like this north direction, exactly north direction में उसका steering है, but साथ में थोड़ी सी wind blow कर रही है towards southeast. Then what will happen to this plane? We know that भाई आगे जाने के साथ साथ wind की वजह से ये overall कैसा जाएगा, थोड़ा सा ऐसा जाएगा, ईस्ट की तरफ जाएगा ना, wind उसको ईस्ट की तरफ लेके जाएगी. And we also know that वो जितना चाहता था उतना ऊपर भी नहीं जा पाएगा ना, because wind will push it a little bit south. So basically the final velocity vector of the airplane would be given as the addition of this in the direction in which it is going plus the velocity of wind. तो overall ये इस orange direction में जाएगा. We also know that a vector can be broken down into its components. So if a boy goes like this from one point to another, and let us say along x-axis, along the horizontal direction he moves 3 meters, and along vertical direction he moves 4 meters, then what we can do is we can represent this vector as 3, 4. This is called as breaking down a vector into its individual component, x component and y component. Once we have broken down two or more vectors, we can easily add their x component separately and y component separately. जैसे कि ये वाला एक वेक्टर था 8,13 and we have this another vector 26,7. Yes, if we want to add them, what do we do? So we don't even need to make all this diagram. What we can do is simply add their x components 26 plus 8, which will give 34, and simply add their y components separately, which will give 20. So this resultant, the resultant, that is the total addition of this first vector plus this second vector, would be totally 34, 20. Yes, all this we had studied last year. After this, we studied the difference between uniform and non-uniform motion. A motion is called uniform when it moves with a constant velocity. In this case, the graph between distance and time or displacement and time would be a straight line. Whereas if the magnitude of velocity or the speed is changing, then what we get is called as non-uniform motion. In this case, the distance time graph won't be a straight line. As you can see, in consecutive or successive time interval, है ना, पहले time में equal amount of time भी अगर तुम लोगे, तो in the first time interval it has covered a lesser distance this much. Whereas in this second time interval, now it is covering a larger distance. Correct? Its velocity is increasing in this case. So it is a non-uniform motion. After this, very important, we had studied the three equations of motion of uniform acceleration. तो उसके पहले एक्सेलरेशन को अपन डिफाइन कर देते हैं. एक्सेलरेशन इज रेट ऑफ चेंज ऑफ वेलोसिटी. बोले तो रेट ऑफ चेंज का मतलब क्या कि भाई वेलोसिटी कितना चेंज हुआ एंड कितने टाइम में हुआ. राइट, इट्स यूनिट वुड बी मीटर्स पर सेकेंड और मीटर्स पर सेकेंड स्क्वायर. Correct? So we will say acceleration is v minus u by t, or v equal to u plus at upon rearranging this equation. This is our first equation of motion. This s equal to ut plus half at square is the second equation of motion, and v square is equal to u square plus 2as is the third equation of motion. Now all these equations would be applied in numericals. So here are a few tips regarding how to solve numericals. I know all of you would be knowing how to solve, but let us do a brief recap. So we know that if a body starts from rest, then its initial velocity is taken as 0. But its acceleration would not be 0, है ना? And if it is given that a body comes to rest finally, मतलब उसका final velocity 0 लेना है. If it is said that a body moves with uniform velocity, तो यूनिफॉर्म वेलोसिटी क्या कि मतलब वेलोसिटी कांस्टेंट है. वेलोसिटी कांस्टेंट है तो चेंज नहीं हो रही है, मतलब एक्सेलरेशन 0 है, बिकॉज एक्सेलरेशन इज रेट ऑफ चेंज ऑफ वेलोसिटी. सो इफ अ बॉडी मूव्स विद यूनिफॉर्म वेलोसिटी, देन इट्स एक्सेलरेशन इज 0. ऑल्सो व्हेन अ बॉडी फॉल्स अंडर ग्रेविटी, राइट, लेट अस से दिस इज अ बॉल एंड इट इज फॉलिंग फ्रीली अंडर ग्रेविटी, तो चाहे बॉल का मास कुछ भी हो, इट्स एक्सेलरेशन वुड बी g, दैट इज 9.8 और 10 meters per second square in the downward direction. And a sign convention while solving these numericals is very important. So what we do is, पहले से ही हम कोई एक डायरेक्शन को पॉजिटिव मान लेते हैं. Then all the quantities in this direction are considered positive, while velocities or acceleration in this opposite direction are considered as negative. If sometimes you encounter a problem where एक्सेलरेशन चेंजेस थ्रू आउट द क्वेश्चन, है ना, एक्सेलरेशन भी कांस्टेंट नहीं है, तो हम अपनी इक्वेशंस ऑफ मोशन नहीं लगा पाएंगे, बिकॉज ऑल दीज थ्री इक्वेशंस ऑफ मोशन आर बेस्ड ऑन यूनिफॉर्म एक्सेलरेशन. सो नाउ व्हाट डू वी डू? सो व्हाट वी कैन डू इज वी कैन ब्रेक द प्रॉब्लम इनटू सेवरल पार्ट्स सच दैट द एक्सेलरेशन इन ईच पार्ट इज कांस्टेंट. तो अगर ऐसा बोला है कि अ पार्टिकल गोज फ्रॉम ए टू बी विथ एन एक्सेलरेशन ऑफ 2 meters per second square, and then from B to C with an acceleration of 4 meters per second square, तो अपन क्या करेंगे? We will not be able to solve the entire problem from A to C. What we need to do is break it down into two problems. Yes, solve first from A to B and then B to C. सारी equations of motion तुम A से B के लिए लगा सकते हो और फिर अलग से B से C के लिए भी लगा सकते हो. Then we studied subtraction of vectors. So here you can see two vectors. This first is A vector like this, and the second is B vector like this. Now what we want to do is we want to calculate A vector minus B vector. तो माइनस बी वेक्टर करने के लिए क्या करना पड़ेगा, सबसे पहले तो ये जो बी वेक्टर है इसको उठा के ऐसे रिवर्स कर दोगे, है ना, तो वो माइनस बी वेक्टर हो जाएगा. नाउ what we have to do is simply add a vector and minus b vector. तो अब एडिशन ऑफ वेक्टर्स तो अपने को आता ही है. We join these a vector and b vector head to tail and then join the tail of first vector with the head of last vector and we get a minus b vector. Whenever somebody says change in any vector, change का मतलब क्या होता है, change simply means final minus initial. So for example, change in velocity would be final velocity minus initial velocity. Next we had studied few graphs. So first graph that we'll look right now is position versus time graph. It means that at some time t, the body was at point A, है ना, this was its position, while at some time t dash, the body was at point B. If the position time graph is a straight line, it means that वो अपना position uniformly increase या decrease या change कर रहा है. It means that it is moving with a uniform velocity. It means that this is a uniform motion. Whereas if the displacement time graph or the position time graph is not a straight line, in this case the graph is given by this yellow line, then we know that this motion is not uniform. अपन यहाँ पे देख रहे हैं कि यार at some time later on, मतलब motion के end वाले part में its displacement is increasing very quickly with time. It means that towards the end its speed is much higher than it was towards the beginning of the motion. पोजीशन टाइम ग्राफ से हमें क्या मिलता है, हमें वेलोसिटी मिलती है. एंड हाउ डू वी गेट वेलोसिटी, सो वेलोसिटी इज सिंपली स्लोप ऑफ पोजीशन टाइम और डिस्प्लेसमेंट टाइम ग्राफ. एंड हाउ डू वी कैलकुलेट स्लोप ऑफ एनी वाई वर्सेस एक्स ग्राफ. यस, ये पोजीशन डिस्प्लेसमेंट वगैरह एक सेकंड के लिए भूल जाओ. अगर कोई भी वाई वर्सेस एक्स ग्राफ है तो अपन उसका स्लोप कैसे निकालते हैं. सो स्लोप बिटवीन दीज टू पॉइंट्स ए एंड बी is simply calculated as delta y. This portion would be delta y upon delta x. इस केस में अपने y एक्सिस पे क्या है, तो अपने y एक्सिस पे पोजीशन है ना, तो अपन यहां पे लिख देंगे कि चेंज इन पोजीशन अपॉन चेंज इन टाइम. यस, so slope of xt graph would give me the velocity. Next is a velocity time graph. I'm sure all of you would be knowing that a slope of vt graph would give me acceleration, whereas the area under vt graph would give me displacement of the particle. Remember over here that area above the graph is considered positive, whereas अगर पार्टिकल इसके बाद भी ऐसे मोशन आगे कंटिन्यू रखता तो अब हमें टोटल ये एरिया को भी लेना पड़ता, बट नाउ दिस ब्लू कलर्ड एरिया वुड बी टेकन एज नेगेटिव. Like this, area under VT graph would give me displacement. And if we take the magnitude of all these portions individually, yes, this triangle plus rectangle plus triangle plus magnitude of this, then it would give me the total distance covered. So this was all that we studied in the first 4 lectures of last year. I hope all these points are clear. If not, I would request you to ask your respective teachers or go to doubt sessions and get all these cleared. Now we'll move on to questions. As soon as you see any of the question, please pause the video at that instant, try to solve the question on your own, and once you get the answer, you can continue with the video. So here you can see the first question on your screen. Please pause the video. I will now start with my solution. So the question says that a train starts from a station with an acceleration of 1 meters per second square. Because it says that the train starts, मतलब क्या है कि अब तक वो रेस्ट पे थी, अभी जस्ट स्टार्ट कर रही है, तो उसका इनिशियल वेलोसिटी अपन 0 ले लेंगे ट्रेन का. Acceleration of train is given as 1 meters per second square. Then it says that 48 meters behind the train there is a boy, and this boy is moving with a constant velocity of 10 meters per second. We are supposed to calculate the time after which the boy will catch the train. So now let us say that the boy and the train overtake each other somewhere over here. Let us say at a distance x from the start point of train. अब क्या हम इक्वेशंस ऑफ मोशन लगा सकते हैं? Yes, and let us say that it takes time t for the overtaking to happen. So now we know that in time t, train covers a distance x with some acceleration. So applying the second equation of motion, we can say that x equal to initial velocity of train into t plus half times acceleration of train into t square. Initial velocity of the train is given as 0, and hence we will say that x is equal to half into 1 into t square. This is our first equation. Similarly, for the boy also we can write what is the displacement of boy in this time t. So the boy has moved total x plus 48 meters, है ना, ये भी तो cover किया है boy ने. So total we can say that x plus 48 distance covered by the boy is equal to initial velocity of boy into t plus half acceleration of boy into t square. Since the boy is moving with a constant velocity, its acceleration is 0, है ना, तो ये पार्ट 0 हो जाएगा and we finally land up with displacement is equal to velocity into time, our old formula. Yes, substituting the values, x का वैल्यू ऊपर से मैं देख रहा हूं हाफ ए टी स्क्वायर है, I substitute it in this second equation and I get half a t square plus 48 is velocity of boy 10t. Yes, a value of acceleration is 1, so I'll write it as half into 1 into t square. Now this is a quadratic equation. By now I am sure all of you know how to solve this quadratic equation. If you solve this equation, you will get two answers, time as 8 second and time as 12 second. ये दो बार ओवरटेकिंग होगी. दो बार क्यों होगी? क्योंकि स्टार्टिंग में ट्रेन का स्पीड 0 है, वो धीरे धीरे स्पीड पकड़ेगा and meanwhile the boy will overtake the train at some point. But after that, boy will go at a constant speed while the train speed will go on increasing. Yes, hence after some time again the train would overtake the boy. But ये अपने को पूछ रहा है कि first time कब होगा जब boy train को catch कर लेगा. तो first time का answer would be 8 seconds. I hope it is clear. This is the next question on your screen. Please pause the video. I will now begin with my solution. So body covers equal distances with these three speeds. So let us say in the first distance AB that it covers with a speed of 60 kilometers per hour. This distance is D. This second distance is also D with a speed of 20 kilometers per hour. And this third distance is also D when the car moves with a speed of 10 kilometers per hour. Overall, the car moves from point A to point X with these different speeds. Average speed क्या होती है? Total distance upon total time. ये point A से लेके B तक जाने में कितना टाइम लगेगा? तो time would be distance upon speed, है ना? पहला टाइम इतना लगेगा. फिर B से लेके C तक कितना टाइम लगेगा? तो this time would again be the distance upon this speed 20. Whereas this time would also be the same distance upon speed 10. Now, as per the definition of average speed is total distance, or in fact they are asking average velocity. So now we will calculate average velocity as total displacement upon total time. Total displacement in this case, as you can see, is 3D, whereas total time is t1 plus t2 plus t3. That is d by 60 plus d by 20 plus d by 10. Yes, ये calculation सबको करनी आनी चाहिए denominator लेके. I'll just directly write the final answer. So this would give me average velocity as 18 kilometers per hour, but all the options are in meters per second, so we'll ultimately have to convert it. I'm sure you know how to convert it. So we do 18 into 5 by 18, which gives me 5 meters per second. Hence option D is the answer. Now you can see the next question on your screen. Once again, please pause the video. I will now begin with my solution. The car passes through points P and Q separated by some distance. Its speed at P is 30 kilometers per hour, while that at Q is given as 40 kilometers per hour. हमसे ये पूछा जा रहा है कि मिडवे बिटवीन P एंड Q कार का वेलोसिटी या स्पीड कितना होगा. सो दोज ऑफ यू आर थिंकिंग कि यार बीच में 30 और 40 के बीच में तो 35 आता है, तो यहां पे स्पीड 35 हो जाएगा. दिस ऑब्वियसली इज द रॉन्ग आंसर. व्हाई इज इट द रॉन्ग आंसर? बिकॉज प्लीज रिमेंबर दैट एक्सेलरेशन इज यूनिफॉर्म. इट मीन्स व्हाट? टाइम के साथ साथ वेलोसिटी कॉन्स्टेंटली बढ़ रही है. इट मीन्स व्हाट? कि वेलोसिटी इंक्रीजेस डायरेक्टली विथ टाइम, नॉट विथ डिस्टेंस. सो वी कैन से दैट यार आधे टाइम पे स्पीड आधा होगा बट आधे डिस्टेंस पे नहीं कमेंट कर सकते. So we will have to use the formulas. Let this total distance PQ be 2x और P और Q के बीच में एक पॉइंट अपन ले लेते हैं A. Yes, तो ये PA का डिस्टेंस x रहेगा और AQ का भी डिस्टेंस x रहेगा. And also let the velocity at A be some v. So applying equation of motion between P and A, we can write v square minus 30 square equals 2ax, and applying the same equation between A and Q, we can write final velocity as 40. Therefore 40 square minus v square equals once again 2ax. Now I simply subtract these two equations, that is equation 2 minus equation 1, and it gives me 40 square plus 30 square minus 2v square is 0. It means what? 2v square is 40 square 1600 plus 30 square 900. After this, please solve it on your own. I am directly writing the final answer. The final answer is 35.35 kilometers per hour. This is our answer, option D. Please note that all these speeds were not in SI units, and I don't need to convert them also because equations of motion can be applied without SI units also. Although it is preferred that you convert, but over here we will get answer without converting also. Now you can see the next question on your screen. Please pause the video right now. I'll continue with my solution. A displacement time graph of a particle is given, and it is being asked that when is the instantaneous velocity of the particle negative. So we know that instantaneous velocity कैसे मिलती है displacement time graph से. So basically, as we just discussed, it is the slope of displacement versus time graph. किसी भी दो पॉइंट के बीच में एवरेज वेलोसिटी निकालनी है तो हम ऐसे स्लोप ले सकते हैं डेल्टा y बाई डेल्टा x. अगर इंस्टेंटेनियस वेलोसिटी निकालनी है पॉइंट C पे तो हम क्या करते हैं, तब हम वहां पे एक टेंजेंट ड्रॉ करते हैं और इस टेंजेंट का स्लोप देखते हैं. सो राइट नाउ एज वी कैन सी the slope at C is positive है ना, the hill is going upwards. At D the slope is almost 0. At E the slope is going down, right? The slope is negative, the graph is going down. Whereas at F also the slope is positive. तो velocity कहाँ negative होगी? जहां पे slope negative होगा. So we have only one answer over here, that is option C. This is the next question on your screen now. Please pause the video. I will begin with my solution. A displacement time graph is given and we are supposed to convert it into its corresponding velocity time graph. तो displacement time graph से velocity कैसे आती है? As we have just studied, velocity is the slope of displacement time graph. सही है क्या? Now if we try to calculate the slope, we can see that the slope is positive. Slope अपन कैसे देखते हैं? एक पॉइंट पे tangent बनाते हैं, and because this tangent is going up, this graph is going up, we can say that over here the slope is positive. Same over here also, over here also. Now at somewhere around 5 seconds in between, over here the slope is 0 and hence the velocity is 0. After that the slope is negative and the velocity is negative. तो velocity कैसी होनी चाहिए? स्टार्टिंग में पॉजिटिव, फिर बीच में कहीं 0 और फिर नेगेटिव होनी चाहिए. If we look at the graph, only one graph satisfies these conditions. स्टार्टिंग में पॉजिटिव है वेलोसिटी, फिर 0 है और फिर नेगेटिव हो रही है, और किसी भी ग्राफ में वेलोसिटी नेगेटिव नहीं हो रही है. Hence option C is the answer. This is the next question on your screen now. Please pause the video. I will begin with my solution. A ball is thrown vertically upwards from the top of a tower. एक टावर के ऊपर से बॉल को ऊपर की साइड फेंका. with a velocity of 4.9 meters per second. It strikes the ground near the base of the tower, मतलब बॉल ऐसे ऊपर जाएगा और फिर नीचे आ जाएगा after a time of 3 seconds. We are supposed to calculate what is the height of the tower. Now, there are two ways of doing it. First, we can either break the problem into two parts. तो पहले अपन देखेंगे कि यार बॉल को यहां से फेंका जाता है टॉवर के टॉप से, तो उसको ऊपर तक जाने में कितना टाइम लगता है ना, 4.9 मीटर्स पर सेकंड के हिसाब से वो कितना ऊपर जाएगा और कितना टाइम लगेगा. दैट वुड बी पार्ट वन ऑफ द क्वेश्चन. देन बेस्ड ऑन द न्यू हाइट, नाउ यू कैन कैलकुलेट अब उसको ग्राउंड तक नीचे आने में कितना टाइम लगेगा, एंड बेस्ड ऑन ऑल दिस इंफॉर्मेशन यू कैन कैलकुलेट द हाइट. This would be the long way of solving a problem. Now let us try to learn a shortcut. If you see the equation of motion s equal to ut plus half a t square, यहाँ पे s क्या है, displacement है, u initial velocity, a is the acceleration. The only condition for applying this equation is that it is valid only for uniform acceleration. Acceleration change नहीं होना चाहिए, acceleration हमेशा कांस्टेंट होना चाहिए. क्या जब बॉल ऊपर जाता है तो उसका एक्सेलरेशन कितना है? इट इज 9.8 मीटर्स पर सेकेंड स्क्वायर डाउनवर्ड्स. जब वो टॉप मोस्ट पॉइंट पे है तब उसका एक्सेलरेशन कितना है? इट इज सेम, बिकॉज अगेन ग्रेविटी इज द ओनली फोर्स एक्टिंग ऑन इट एंड एक्सेलरेशन इज f by m विच इज 9.8 मीटर्स पर सेकेंड स्क्वायर. जब बॉल नीचे आता है तब भी उसका एक्सेलरेशन सेम है, 9.8 मीटर्स पर सेकेंड स्क्वायर डाउनवर्ड्स. So basically, throughout its motion, its acceleration is constant in magnitude as well as direction. हमेशा नीचे की तरफ है. So what I am saying is, rather than solving for some intermediate point B, I can apply this equation of motion directly from point A to point C. Yes, this is the critical piece of this question. Please try and understand. Even though the direction of velocity is changing, पहले ऊपर जा रहा है फिर नीचे जा रहा है, all we have to do in this question is apply the equation of motion directly from point A to point C. Point A से point C के बीच में displacement कितना है? So considering upwards direction as positive and downwards as negative, भाई बॉल क्या है ओवरऑल सब फाइनली ऊपर जाके नीचे जाके फाइनल डिस्प्लेसमेंट बिटवीन पॉइंट्स A and C is how much? माइनस h. माइनस क्यों? क्योंकि नीचे की साइड h हाइट डिस्प्लेस हुआ है. वो इनिशियल वेलोसिटी इज 4.9, ऊपर की साइड है इसलिए प्लस 4.9. टाइम इज गिवन एज 3 सेकेंड्स प्लस हाफ. एक्सेलरेशन कितना है? 9.8 मीटर्स पर सेकेंड स्क्वायर, बट इन द डाउनवर्ड डायरेक्शन, दैट्स व्हाई नेगेटिव. सो माइनस 9.8 meters per second square into time is 3 again, so 3 square. On solving this, you get height of the tower as 29.4 meters. Now none of the option is exactly matching, so this is a slight issue on the option making part, but we can, for now, in order to tick one answer, we can say that this is the answer. However, I hope you have understood the important concept over here, that even though direction of velocity changes, we can still apply equation of motions directly between points A and C. This is now the next question on your screen. Please pause the video. I will now begin with my solution. So there is a tower and two balls are dropped from the tower but 2 seconds apart. तो पहला बॉल फेंकते हैं, फिर वो थोड़ा नीचे चला जाता है, उसके बाद दूसरा बॉल और फिर से फेंका जाता है ना, 2 seconds later. Then the question being asked is, when are these two balls 40 meters apart? तो जब दूसरा बॉल छोड़ेंगे उसके बाद भी ये पहला बॉल थोड़ा और नीचे जाएगा, दूसरा बॉल भी थोड़ा और नीचे चला जाएगा, and after some time the gap between them would be 40 meters. Now if you see, let us assume that the first ball has been in air for t seconds. तो ये जो दूसरा बॉल है ये कितने सेकंड के लिए हवा में रहा है? इसको 2 सेकंड बाद छोड़ा था तो ये 2 सेकंड कम रहा है हवा में. So this has been in air or in motion for t minus 2 seconds. Now applying equations of motion, we know that the displacement of first ball from the topmost point S is ut plus half at square. U for both balls is 0 because it is said that they are dropped from rest, initial velocity 0 है. So we can say simply half into 9.8 into t square. This is the displacement of first ball. Displacement of second ball similarly is half into acceleration, that is 9.8 into t minus 2 का square, है ना, 2 सेकंड कम रहा है. In this I am considering downward direction as positive and writing acceleration as plus 9.8. It is given that these two balls are 40 meters apart. It means S1 minus S2 is 40 meters. Substituting the values of S1 and S2 from these equations into this third equation and solving this equation, we get, guys, in the question G is given as 10, so I will put all my values of G as 10. Further solving this, I get the time as 3 seconds. Hence, this is the answer. You can now see the next question on your screen. Please pause the video. I will begin with my solution. A ball dropped from the top of this 9-storied building drops to the floor in 3 seconds. So we can conclude from here, we can get the height from here, right? In 3 seconds, the ball will cover a distance half into 10 into t square. That is 45 meters. ये 9 मतलब ये total height of the building हो गया है ना. 9 floors correspond to 45 meters. It means that each floor is of 5 meters. Now it says that how much does the ball fall in the first second. So in the first second we know that displacement is half into 10 into 1 square है ना. एक सेकंड में कितना जाएगा, half g t square. This comes out to be 5 meters. 5 मीटर बोले तो कितने फ्लोर्स गया, वो एक फ्लोर गया है ना. Hence option A is the answer. Here is the next question on your screen now. Please pause the video. I will now begin with my solution. One ball is thrown from a top of a 100 meters tower. Dropped बोले तो इसका initial velocity 0 है. At the same instant, another ball B is thrown vertically upwards with a velocity of 254 meters per second. अब क्या होगा कि ये बॉल नीचे आएगा और ये वाला बॉल ऊपर जाएगा. At some time, both these balls will collide. We are supposed to calculate when will this collision occur. So let us say both these balls collide at time t. And this displacement of the ball is SA, while this displacement of ball B is SB. How can we write SA? Displacement of ball A can be said as UA into T plus half G T square. Over here it is given that UA is 0 and hence we make this part 0. Similarly, displacement of B, considering the upward direction as positive, we can write it as UT. U of B is 254 into T minus half G T square. माइनस क्यों किया, क्योंकि मैंने ऊपर की साइड पॉजिटिव लिया है तो इसका एक्सेलरेशन नीचे की साइड है G, which will be taken as negative. If we add both these equations 1 and 2, we get SA plus SB is equal to 254T. Now ये SA और SB मिला के क्या है? If you see, distance covered by A plus that covered by B would be equal to the total height of tower, right? दोनों मीट हुए, एक ऊपर से गिरा है, एक नीचे से फेंका गया है. When both of them meet, the total distance covered by one plus the another would be equal to length of the tower. Hence, 100 is 254T, 0.393 or approximately 0.4 seconds. Hence, option B is the answer. This is the next question on your screen. Please note that this red colored line or this red colored graph represents the velocity as a function of time. The black marks are just an indicator. For example, you can see that at t equal to 3 seconds, the velocity is 10 meters per second. Having said that, please pause the video now. I will begin with my solution. Velocity time graph is given and distance covered by body is asked. तो डिस्टेंस या डिस्प्लेसमेंट अपन कैसे निकालते हैं वेलोसिटी टाइम ग्राफ से? डिस्प्लेसमेंट इज the area under velocity time graph. Same for distance also. In this case distance would be area under this velocity time graph. तो अपने को कुछ नहीं करना है, ये जो ब्लू कलर से शेडेड है ये पूरा एरिया निकालना है. Obviously we don't have a direct formula for such strange objects, so what we can do now is divide this entire area into several shapes such that we will be able to write down the answer. तो एक शेप मैं ले लेता हूं, ये पूरा रेक्टेंगल, इसका एरिया मेरे को लिखना आता है, इसको A1 कॉल करते हैं. A1 would be equal to base, this base is 3, 4 minus 1 3 into height 10, that is 30. Similarly area 2 I have taken to be this triangle, and therefore this area 2 would be half into base, base इसका 1 है, into height, the height is 20, this gives me 10. Next A3 I will take as area of this rectangle A3. This would be equal to base 1 or length 1 into height 10, that is 10 once again. And lastly this area A4, half into iska base 1 into height 10, that is 5. Now the total area would be the sum of all these areas, A1 plus A2 plus A3 plus A4, and that would be equal to 55 meters. This area is nothing but displacement, and hence we can say that displacement of the body in these 4 seconds is equal to 55 meters. Hence option D is the answer. That was your last question. This brings us to the end of this particular lecture. I hope you have understood all the concepts. If not, please feel free to ask us during our doubt sessions. I'll see you in our next lecture. Thank you, students.